Good morning to one and all present here. I welcome you for the lecture series. Uh, our today's discussion is going to be in hydraulics and pneumatics course. We will see a small case study of how we transport solar PV cell in the manufacturing plant. So the industry which I have taken this case study is from Tata Power Solar. The challenges in transporting solar panel is like this. The solar panel manufacturing company was facing the problems in transferring the solar panels from one station to another station. The solar panel are made up of glasses and it is very delicate. So most of the time while transferring, it was breaking. Like glass pieces, they tend to break and there will be a brittle failure. So what is brittle failure? Without any caution, it will break. We cannot restore the product and it cannot be reused also. So the company was breaking more panels than they are manufacturing. Also, they were facing the problem of transferring huge dimension the solar panels. The solar panels length and width, it's a rectangular solar panel and square solar panels usually we use. The 14-inch diameter parabola glass shaped bowled solar panel they made was very delicate. So every time while transporting, it was either being dropped or being squeezed into breaking point. So they were disappointed with the downtime and broken product they had suffered with what had been commercially available. Most available grippers in the market was not able to handle fragile glass. Also, the magnetic pick iron transport is not possible as the glass is not magnetic. So usually what we'll do when we lose any metal pieces in our home, usually we'll take some magnets and then search for that so that that gets attracted. But these solar panels, even though it has some metals in it, it is very difficult to take as the glass is fragile. We cannot use magnetic sticking. So grippers is handle which is associated with robotics hand. This grippers will provide more kind of pressure on the solar panel glass. So what can be done? The objective of this case study is to find a solution. It must cater ease of transportation of glass materials during manufacture and a low cost involved in the manufacturing process. So usually the solar panel flow line is like this. So they start with simulation, then they go for panels, uh, framing and trimming, then they will go for sandwich layers manufacturing, that is lamination process. Then they are going for bussing like connections. Then they are going to assemble the string. Finally, it is being tested at this point. Crystalline silicone is used to manufacture these solar panels. And the thickness of the solar panel is 2.5 mm to 4 mm. So we have three kinds of solar panels here. One is of thin film, monocrystalline, and polycrystalline. So pneumatic grippers were used. And what can be done to transport this? So we can transport, we have so many ideas. We can transport with hand. So is it possible to hire so many people to for transportation purpose? And it needs coordination, space, everything. So there comes one constraint. And again, we can move it in a conveyor, right? So that will be another idea. And conveyor, again, it will get makes the solar panels damage. And what else the other idea is? Like we can use vacuum cups. Yes, that will be a right idea. Let us see the solution. The pneumatic grippers were used, which is specifically a type of pneumatic actuator that involves either a parallel or angular motion. The tooling jars figures a rubber suction diaphragm that will grip the object. It would be better understandable by seeing this picture. So this pneumatic panels is being grabbed by using this rubbers, right? So this rubbers suction cup will not damage the solar panels as well. It will create strong suction of this solar panels and the pressure is controlled. Pneumatic air is being supplied from the compressor. So this will be the right method or the right procedure to transport to meet our objective of the case study. Hope you enjoyed the case study. Thank you.